Okay, so we are going to start. So please, if anyone got a question or wants to discuss a certain topic in this presentation, it's not just a presentation. We can have an interactive discussion, and you can ask your questions, but please in the comment section so that we can have an organized presentation and discussion. So I'm going to start first of all by talking about the topic, which is the merge. So a few weeks from now, and we all know that the merge happened on Ethereum, and we have now Ethereum 2.0. And for this topic, maybe you are wondering, maybe some of you don't know what is Ethereum or what is the new features of this added value of this merge. We are going to go maybe a little back in the past, and for the Ethereum, the launch was, of course, with proof of work, sorry, but the intended version was with proof of work consensus mechanism. And despite the, let's say, maybe some difficulties, I'm not sure if it's technical difficulties or it's just a choice, but Ethereum launched with proof of work. However, the researches on the proof of stake continued, and we now have a fully fledged proof of stake consensus algorithm that we just launched. So for the integration part about the merge, we are going just to give you bullet points here and about the strategy. So the developers of Ethereum had maybe two choices, like having the integration directly on the mainnet and all the difficulties, technical difficulties, and even how to convince the community directly to switch. So they adopted another approach, which is just having a side chain launched with proof of stake that will test the feasibility and have all the technical stuff running. Then when it's okay and we are sure that it's ready, well, then we integrate it with the mainnet, which is the proof of work chain or Ethereum 1.0. So for the steps of the integration or the steps of the merge, so the first step was the launch of the beacon chain. As I said, it's the proof of stake chain. And then the other advantage of having this chain already deployed is to give time for validators that will, of course, validate the transactions and participate in the consensus mechanism. And the consensus mechanism on the beacon chain was lately added to the mainnet. It's like changing the engine as described on the website. So a better view of the different steps, we are going to go a little bit back in time, and we are going to discuss about how the phases or different phases of this merge happened. Let's assume that we don't know yet that the merge happened, and we are going to simulate the different steps. So the first step was the launch, as I said, of the beacon chain and launch of a deposit smart contract. So here I'm going to give some technical terms, and I will try to explain them in simpler ways, because sometimes in the documentation you will find these key concepts or keywords. So I'll try to do both. So the deposit smart contracts is just regular smart contracts deployed on the Ethereum 1.0, which is the gateway to the Ethereum 2.0. So the idea was to have that smart contract that will accept deposits from all the interested validators or future validators. They want to become validators. They will send about 32 Ether if they want to become an active validator, but you can send any other value more than 1 Ether. The smart contract can accept more than 1 Ether. And of course, in the first phase also, we have the honest validator guide, where we have the different steps that defines the installation, the clients that you need to run in order to have a validator. So that's during the first phase, or phase 0. Then phase 1, we have the upgrade of the Altair fork. It's the first scheduled upgrade for the beacon chain, and the light claims were added, like sync protocol for of course, because Beacon is going to use less hardware or less requirements to run, we have the specification for the light client and the full nodes that will help the light clients to synchronize, and increased validator inactivity and slashing penalty. This is what happened during this fork. And another interesting or fun fact here is that it's the first major network upgrade that had an exact rollup time. What does that mean is that in the past, when we had like major forks or events happening on the Ethereum blockchain, we just knew the exact block or the hash rate that we, according to the hash rate we have. So like we didn't know the exact time. We said like, okay, the event will happen in block number X, and we need to wait just and see how the hash rate will change. Maybe we have multiple miners, maybe we have less. So it was like that. But the new thing with the Beacon chain is that we know exactly the time, and we will see how that was possible. So before the final step, we had two other major upgrades, which are the Arrow Glacier and the Gray Glacier. So nothing interesting happened here. It was just two upgrades, mainly to delay the difficulty bump. The difficulty bump here is, in simpler terms, is an exponential increase in the mining difficulty, so that the proof of work is no longer available for all the miners on the network. So that's the idea behind the difficulty bump. And after two delays, we had finally the last step, so which is the Blatrix upgrade. It's the second scheduled upgrade for the Beacon chain, and it increased, or we have the final validation incentive and slashing penalties. And in terms of when it happens, so it happens in the terminal total difficulty that appears here. So that's most of what we have as steps. So if you have any questions, if anything is not clear, you can just ask the questions in the comment section, and I will try to answer this. So of course we have here the resources. So if you want to check, everything is available on GitHub or on the web page of Ethereum, the website of ethereum.org. So then we are going to talk a little bit about Beacon chain and some specific features about the Beacon chain. So as you know, as we said just now, that the two chains were living in parallel, like we have two chains coexisting, and there were some conditions that had to be met before launching or activating the Beacon chain. So the first thing to mention here, or the first criteria, was the threshold of 16,384 validators. So the Beacon chain was unable to activate or to launch properly before reaching this number of validators, which is required to have the consensus mechanism working as expected. Sorry. So the second thing was the time, exactly. So let's say we had this number of validators already staked their Ether and ready to join. This is not enough. We need to wait to a certain block in the Ethereum 1.0 net. So this is required also to have the final stage and the Beacon chain ready to activate. So we can just explain that by this graph here. So we have this expected timeline. Let's say we have in this block, we deployed the deposit smart contracts. So now everyone interested in becoming a validator can send or stake Ether. Once this step is done, so everyone is going to send their Ether, and we expect to reach the target of 16,000, and this is the first step. And as this happens, we have also the target of the time, which we expect also the launch or the official start of the blockchain to start after it. Just there is a question. I'm going to try to read it. Sorry. Okay, so about the miners, if they were forced to upgrade since the difficulty prevented them from pursuing the mining, no, they could easily just rewrite the software and stay with the proof of work. It was a matter of choice. They decided to continue with the merge, and to be honest, the merge is not finished yet because even though we have the merge, all the staked ether we have can be withdrawn yet. So maybe there are some major event will happen when the withdrawal option will be available for everyone, because right now all the deposited ethers are just locked in this smart contract. And of course, this have some major impacts because some people staked their ether when it was about $4,000, and now it's almost 1,000 and a bit. I'm not sure about the price, but there are some changes. But it is a commitment. It's a commitment from the community to see this go through. Okay, so to continue with this part, so now we have, let's say, more than this target number of validators, and we have reached the exact block that we expect. So here, what's going to happen is that the beacon chain is going to start. The validators will start creating blocks. They will just work on the internal state of the beacon chain, because at the first step, they didn't receive transactions from the Ethereum 1.0 net or blockchain directly. They had just to maintain the state of the beacon chain, like who is validator, what balance each validator have, and all that stuff. So here you can see also that there are some delays between the creation of the first block and the two conditions. So this delay is just to make sure that all the deposited Ether are really going to be on the second chain, because as you know, if we don't wait for a few blocks before the transaction, after the transaction is sent, it may be reverted, and that's a problem. So we will see more in detail what does that mean, and we will talk about finality. So staking. So now the interesting part, we all talk about proof of stake, and staking is green and less energy consuming than proof of work. But let's see how we can really stake. So you will need at least 32 ETH to activate your own validator. It's like being a miner. Here we have full control over the node. It's you are going to take the full reward. You don't need to share it with anyone, but it's also possible to stake less, and you will see how we can we can do that. So as validators, you will be responsible for storing data, processing transactions, and adding new blocks to the blockchain. As I said, the validator is the equivalent of the miner in the proof of work chain. So there are few approaches to staking. You can have solo staking, which is being a validator. You just send the 32 ETH to the deposit smart contract, and you will have the client activated on your infrastructure hardware. So you just start working, and it's the most impactful because here you have full control and you will maintain the network. So here, as I said, it's trustless because you are not going to provide any or to need any services from external entities. So the second option here is that you have the 32 ethers to stake, but you don't have the hardware, even though the hardware is not really expensive. It's just A normal laptop can just be a validator, but maybe you are not interested in having a laptop running day and night. So you can just have a hardware from a provider, and you just set up your validator. And here the only inconvenient thing is that you will have to trust maybe the operator that will give you the hardware, because you will have your private keys, especially that key that signs transactions on hot wallets. So it's a little bit complicated, but it can be done. Okay, so now for the part where we said but it's possible to stake less, we have the pooled staking. So if you have any amount of Ether, no matter how much you have, so you can just join a pooled staking, a pool of staking, and this pool will just stake the Ether you have and give you an ERC20 token that is the equivalent of your Ethers, and they will validate and do all the work for you, and you will get the reward. So here, as you can see, each option got its advantages and disadvantages. Here, you don't have to share any Ether or any rewards with the others, but you also assume all the responsibility. And here, you really trust the pool that you join in order to have the rewards. So if there are no questions regarding this part, we are going to go to the next one. Okay, so for this part, we are going to talk about how to become a validator. And in this part, we are going to go through the different steps required for this to happen. So as usual, we will need the keys, but the special thing about the Ethereum 2.0 is that we need two keys. Two pairs of keys, in fact, because one will be used to sign the transactions and the other will be used to withdraw the money that you staked. Okay, so as you can see here in this diagram, we have two keys. This one is called the validation key. This one is the withdrawal key. And for this part, you can see the impact or the usage of the keys in the first layer and on the first network, Ethereum 1.0, and the second network. So here, once you have the two keys, you will send the public key the public keys to the smart contract, to the deposit smart contract, in order to register. So you send 32 Ethers with the validator public key, withdraw public key, and you sign the transaction. So later you can use the withdraw public key to withdraw your staked Ethers, and this will be used, as I said, in the version 2.0 to withdraw. So this is basically the idea. The role here is to propose blogs, sign attestations online at least 50% of the time. 50% is not a requirement, but 50% you need to be active or online, because this is what will get you profitable gains, and you will really have some gains from the job you do. Okay, so then we have the miner. Okay, so I said the miner, the validator sent already the required Ethers, the 32 Ethers, and he deposited that amount. So the first step is like the status being deposited. Okay, this status will keep for about 7 hours, which is the equivalent of 2048 blocks. So the blocks thing is more accurate than the hours thing, because as you know, we calculate blocks and not hours in the 1.0 version. And this is, of course, we need to wait because we need validation, we need finality of the transactions. Okay. And then once we have the confirmation, we pass to the pending. Pending, we wait for the activation on the Ethereum 2.0, which will be done by the validators. Okay, so they need to be voted by other active validators, and this will take also time, about 32 epochs, and we will see exactly what epochs are. Exactly. So once this is done, we have an active validator currently attesting and proposing blocks, remains here until one of the below events occurs. So you can just keep validating and participating in the network until the balance drops below 16 Ether. So here you stake it 32 Ether, but for some reason you lost some of them, and when you go below 16 Ether, you will be rejected, and you will see exactly why you can lose the ethers you stake. The voluntary exit, so you just decided to go out, and the getting slashed, which means that you will lose a lot of ether and you will get rejected also, but this time forcibly. Is it clear, or there are any questions regarding the different steps or states of the validator? If you have questions, you can just ask them. Okay. So here we are going to talk about a new concept regarding how rewards and penalties are calculated. So we said that a validator can either gain or lose the staked money, and this is depending on how Honest is acting on the network. So how this exactly is done is through two main options. The first one is the current balance and the effective balance. So the current balance is what you have as balance exactly, like the money you staked. That's the current balance. And it's unlimited, even though you only need 32 Ether to stake to activate a validator, but you can send any amount you want. It's not a real issue. However, the effective balance is the balance that is used to determine the reward and penalties, which never exceeds the 32 ethers, and its value is an integer. So I'm going to try to explain through these two diagrams. Okay, so let's say here you stake it 32 ethers in order to activate a validator and start validating. Okay, so first you made some gains, which is okay. Then for some reasons you started to get penalties and losing money. So if you notice here, we have the rate of losing money is getting slower and slower and slower. Why? Because the exact formula of calculating the penalties is affected with by the effective balance. Okay. And then when you just start acting honestly and making some gains, you also start gaining ether again, but the rate is also affected by the effective balance. So let's take an example. You had 32 ether here. The effective balance should be 32. Okay. You lost, let's say, you lost about 5 ethers, and the effective balance will drop about 5 ethers also. Okay. Then you acted honestly and gained, let's say, one ether, and the effective balance will just stay without changing. Why is that? Because the effective balance will just change if you increase the current balance by 1.25. So if you have any gains more than that, it will increase. Otherwise, it won't. It will not increase. And if you lose ether more than 0.5 ether, it will just go down also, and it will not stay the same. So if you lose, let's say, 0.2, it won't change. If you gain just 1 ether, it won't change. That's the main idea. And also the effective balance is an integer, meaning that you won't have any decimals. It's just an integer, which is 32, 31, 30, and that's how it's calculated. So why we exactly have this effective balance and why we have all this complicated stuff? Because in Ethereum, we try to minimize the impact, or at least in Ethereum 2.0, we try to minimize the impact of a single validator having a lot of funds and then being a threat to the rest of the network because they can affect the validation process. So no matter how much you have in Ether, a single validator, I'm speaking about a single validator, reward will just be about 32 Ether, okay? 32 Ether as a ratio to calculate the exact reward you will get, okay? This is the choice of the creators of Ethereum to have this limit, and I explained it to protect the network. I hope it was clear the idea here. Maybe if you have questions, doubts, or if you want to add something, you are welcome. Okay, so if we can continue, then we are talking now about the ETH supply and how it's getting affected by that, and the last changes to the Ether supply. So it really started with the last changes. So in ARP 1559, which changes the way the Ethereum is supplied. So here we before we had just Ethereum or Ethers created, and the issue was with the network is that sometimes when there is a lot of activity on the network, it's just there is no way to have your transactions processed but to add a lot of fees, and these fees are just random. You try to have your transaction processed. So even wallets don't have an exact way to calculate the gas fee. So they just give you an option between maybe slow, average, and fast, and you will try to send your transaction properly, but with the least fees possible. So it wasn't really good. And the idea here was to improve this situation. The goal is not really to solve the problem definitely like having a best solution ever, but at least we want to smoothen the volatility of the gas fee. And this is exactly what happened with this proposal or this upgrade. So the idea was to increase first the block size, the block gas limit. Okay, it was about 12.5 millions, and it's now 25 millions. And how this can help us in this situation. So let's say we have a regular activity on the network. All the blocks are containing 12.5 millions gas limit. And then something happened, maybe something having a new interesting coin or new DeFi application, and there are a lot of activity now. So we have a lot of transactions. Miners will increase the gas limit, and they will create blocks with 25 million as gas limit, and this will will tell the network that okay, we are now at the limits of the execution, and we need to find a solution. So I forgot to mention here that also we have a new thing like base fee for transaction, which is just a fee that any transaction will pay directly. And what happens here when we reach this 25 million limit, which means that the network is saturated, is that this base fee will increase, and it will be like a barrier for the majority of transaction. It will keep on increasing just to prevent most of the transactions from entering, and then we will go back to have less activity on the network and go back to average execution. So what will happen here is that the base fee, of course, will get burned. This is why Ethereum is deflationary in some parts, and there are also minor tips. So aside from all the gas that you use, you can also tip the miner to have a better time of execution, especially if you have an application or a transaction that needs to be processed very fast, like maybe arbitrage application or any other uh, kind of application. Okay. So to continue with the Ether supply, it's also affected by the merge. Why? Because before the merge, we had almost two sources of issuance of the two sources of issuance of the Ether. We had one from the proof of work, which is rewarding the miners, and one from the proof of stake, which is rewarding the validators. So once we had the proof of stake already merged with the mainnet, so the proof of work reward is no longer available, and all we have now is proof of stake reward for validation. Okay. So we are going to see now exactly how the rewards and penalties are calculated. So a penalty is a negative reward. So exactly the idea of penalty is just a negative reward, and it could happen for different things. You can go offline, you can miss something, anything that is that requires a penalty. And here we need to mention that slash is not the same as a penalty. It's something really serious. We did something really bad here, and the slash will just take a lot of your stakes and force you out. That's exactly the difference. And this table here will seem a little bit complicated, but we are going to see exactly the different steps by the end of this presentation. Maybe we can go through it now and then come back to it. So as a validator, okay, so here you have three main things that you will vote on. You are not voting just on the blocks, but you vote on the source target, the source, the target, the head, and I will explain what these are. And once you have these, you can miss one of them, you can have two correct answers and maybe one wrong. So it happens to do something wrong, even if it's unintentional, because you may have a bug, you may have internet connection that goes off, and then you have the reward or a penalty depending on how you scored here, and of course an inclusion delay. So you get also a reward if you vote really fast, which is a good thing, and you get a reward. Okay. Are there any questions before we go to this part, because it's the most important part here? Okay. So unlike Ethereum 1.0, Ethereum 2.0 have a fixed rhythm. So I mentioned that before Ethereum 2.0, whenever we had an upgrade, we just mentioned the block in which the upgrade will happen, and we had no exact idea about when this will happen, I mean the time. Now we can just expect the exact time. Why? Because the Ethereum 2.0 just got the idea of having slots, which are just a time lap of 12 seconds. During these 12 seconds, we are expected to have a new block. So a proposer of a block will just create a proposal of him, donc, and then send it. Maybe we don't have a proposal because the person in charge is not available. He just left the network or something happened. So it's not a requirement. It's a may have. And then you have the second technical term, which is the epoch. The 32 slots are equivalent to one epoch. So we can just divide our timeline into epochs and slots. Okay, so what will happen here is that block proposers selection will happen for each slot, and what does that mean is based on the amount of ether that you staked, one from the validators will be responsible to propose a block with the block proposal. And this selection will happen randomly using the algorithm rando. So this will be a random task, but it's affected with the amount of ether that you stake. Then we have the committees. So we have here this epoch, which is the equivalent of 32 slots, and we have one slot that maybe will contain one block. And the idea here is that the totality of the validators will be split into committees, which are working groups. You can think about it like working groups that are responsible to validate just one slot. They will vote on one slot. Exactly. So validators are split up in committees, and one or more individual committees are responsible to attest to each slot. So when we say attest, we mean vote. The idea here, why we do that, is to have every validator in the network validate only once during one epoch. This is the final target that we want to achieve. And for the committees or the working group, if you want to call them like that, it's just a group of 128 validator. And we will see exactly how they are divided because there are other roles within the committee. And each committee will work internally in order to vote on these slots. So if you can see here, there is the concept of sharding that got introduced to Ethereum 2.0. So if you are a validator working on this slot, you don't need to send your transaction or your vote to the majority or totality of the network. And this is very efficient in order to increase the speed of execution, and it's very much less expensive. So after an epoch, whenever we finish with this phase, all the validators are mixed again and merged to a new committee. So it's randomly selected, and as I said, it's use the random algorithm. And this is what we will explain. So how can we generate random things or random selection in a decentralized system? So the algorithm, which is random here, we can simplify it. It's more complicated than that, but we will take a very basic idea on how it works. So we want to achieve a random value, a random number that will represent the block proposer, and let's say we have 4 participants here, which represent the network. Each one will select or generate a random value on its local machine. Then we have the different values, and we need a function that will take all these inputs and generate an output that is not centralized, because of course we can have a centralized entity that will just generate a random number, but this is of course against the even idea of blockchain or DLTs. So the function I said here is called mixing function. So this is the technical term, and it could be, there are different implementations, but the easiest one, we can just take it as an example here, is to get the different numbers generated as bits and then try to execute an XOR operation on all of them. And of course, we will have a single value that will be represented as the final value. So this is the main idea. Of course, there are a lot of security issues, and here that can be thought about it. And of course, there are solutions like what happens if, for example, let's say these three people send their randomly generated numbers, and this person here just waited for the others to finish this task in order to see the values sent from them and send a value that will suit him in order for him to be selected, which is a very common thing. So many mechanisms are added, but the main feature here is hashing the exact values and then sending the proof is one way to go through this issue. Are there any questions? Okay, just we have a question. I will Genesis block. Okay, so for the Genesis block in Ethereum 2.0, it's when we say we have the merge of Ethereum. Uh, when we say that we have the merge, it's all about having the consensus mechanism from the proof of stake chain, which is the beacon chain, and we just provide all the states this existing in the Ethereum 1.0. It's not the same Genesis, but it's just giving or providing the state, the complete state of the Ethereum 1.0 to the new consensus mechanism. Okay, so just other changes that may be interesting for you is the block structure, because many things changes on Ethereum, and we have new parameters that need to be added. Of course, we have some of the old ones, but mainly we have here the epoch. So if we consider this a block, then we need to know exactly to what epoch it belongs, the slot to which it belongs, and we have the status, because each let's say block have a status, and you will see exactly what we mean by status of a block, and other attributes like graffiti, which is just random data that you can add at the stations, which are the votes of the validators, and deposit, which is the amount of attestations included in this block. Okay, so now we get into more technical stuff, but I will try to make it simple. So when we said earlier that a validator is voting on three different aspects, the source, the target, and the head of the chain, this is exactly what will happen. Let's say here we have four epochs. Okay, and in every and each epoch we have the 32 slots containing maybe one block or no blocks at all. So the attestation or the vote of the validator will contain these information: the slot, which to which it belongs, and the index of the which is the identifier of the validator in the committee, and then they will choose the head. The head, which what does that mean? The head is the last block visible to the validator on the chain. So it's like asking for what is the last block that you are seeing right now. And this, of course, depends from one validator to another, because as you may know, on the blockchain, we have forks. We will go to that soon. Forks can happen. Just let's take the example of the fork here. We have a regular chain, okay? In slot 1, we have block A, in slot 2, we have block B, on slot 3, we have block C, and on slot 4, we skipped a block. So the person in charge here of creating the block just wasn't available, and then in slot 5, a new block was created. However, on slot 6, the validator or the creator of the block here, the block proposer, didn't receive the block on slot 5, because it can be due to network latencies, or maybe they are trying to act dishonestly. It depends, but the most important thing is that we are on the state of work. So just regarding the question about the prices, if they get affected by the merge, just the gas fee are currently getting less and less. It's not really requirements, but to go down, but if people are going, it depends really on the community and how they are going to act. If people are after the activation of the withdrawal option are going to just take their money and leave, then this will drop the price of Ethereum. It's very complicated to say how things are going to be, but we expect the best. Okay, see you. Thanks. Another question. So saying is good alternative to mining for people who wants to avoid buying expensive hardware, paying E. Yes, it is a good alternative, but it's not that simple to say. Of course, it will take less energy to operate a proof of stake chain, but the issue here is that not everyone got the 32 ethers to become a validator, and if you became if you don't have the 32 ethers, you can join a pool, which is similar to pools on proof of work. So maybe the most impactful thing here is the proof of stake, not being consuming a lot of energy.